Broadcast is now starting. All attendees are in listen-only mode.
Okay, well, let's start with practicals today. Hive internal table, just in a quick note, what we have seen yesterday. Started with Hive, then we compare HQL and SQL, internal metastore of Hive. We have three different types: local, embedded, remote, then standard data type, complex data type, then where Hive data will store, how Hive will run a query, and we know Hive cell also. To go to Hive cell, we have to type sudo hive here. So in this terminal, we'll type sudo hive. And one more option was in hue. Okay, so we can access this module or service from both option. We'll wait for this. Yeah, once this is open, then we'll create today first internal table. And we know the definition of internal table, that when we drop table data metadata, both gets deleted. So first I will prove all the point which we have discussed yesterday, like schema on read. What is a schema on read? How can we check it practically? Before going to any table creation, first I will create a new database. So let me see how many databases are there. I'll drop some of them. Drop database complex. Okay, the error is coming because we have table inside this database. So whenever you have any table inside the database, we need to cascade it. Cascade is like perform a multi-process. It will delete all the table and then this database also. db1, two databases are there. Remember this point. Okay, many time we don't know that what is the use of this cascade. So cascade is dropping your database along with the table. So if database is empty, you can directly call drop database table name. If database is having a table and then we have record also in that table, then you can use this cascade. In English, this cascade means multi-threading. So I can say this is a multi-threading technically, or in English, I can say this is a multi-process. This thread is nothing but a process, multi-process. We'll create one table. So because I want to start from scratch, so create database. We'll give this database name as May. Create database May. Use this database and create one table. So you can even handle here unstructured data, we also say in Hive. So first I'll create one sample data using text input. So if this is my terminal, I'll open this terminal and create a file, cat sample dot extension. You can give anything, .txt, .csv, .tsv, because Hive can handle multiple types of data. I'm starting with the text data by default. As we go move forward, we'll see other format also. So sample.txt, and there I will write this is text data which comes under unstructured category. I'll just write this, enter, control T. So this is a file, and I want to create a DDL for this file, that how can I store this table, this data in my table. So create table. You can give text info. This is my table name. How many fields are there? So if data is unknown, right, we don't know how many fields are there because we don't know the delimiter currently. And if you don't know the delimiter, then we call it a unstructured data. So you can't keep this as space as a delimiter. Remember, many times we think that can we use this space as a delimiter? So if you use this space as a delimiter, then you'll have to create this many number of columns, and this all the data will go to column one by one. Currently, this is unstructured, and hence I'll say just one column. So that is dummy, and data type is string. Since this is just one row, I can give a semicolon. Semicolon is your termination. So once the statement is done, give the semicolon and enter. So tables. So text info is there. Now if you want to see definition of this table, then there are many commands. I'll start with first command, desk table name, and desk stand for describe. Desk text underscore info, and hive is case insensitive. Okay, you can give uppercase, lowercase, it will not complain you. So when you type text underscore info, you can see there is one field named dummy, and data type of it is string. Similarly, can I take extended information from here? So I'll type extended text underscore info. And when I type text underscore info, I can see the detailed information. Okay, I'll read this for you. So table name, I was starting from table name. This is my table name. This is my database name. Who is the owner of this directory? So root is owner. Create time. This is based on the timestamp. Last access time, I have not yet accessed this. That's why this is 0. Retention period. Retention means you want to delete this table after 5 days, 10 days, 20 days. So we can even set this also, that automatically after, suppose this is a temporary table. Okay, I'm just creating this table for sampling purpose to sample some of the data, and then I'm giving that after 10 days I want to delete this table. So I don't want to delete this manually. The moment it reaches to this 10 days with the same hours, minute and second, then automatically this table will be deleted. But in order to do that, we need to set this time. Currently this is not set, so coming as 0. Field schema, we have dummy as column name, string as data type, comment null. So if you do not pass any data, by default it will keep null for that. So by default, hive will hold null on the record which is not present or not matching. Location. This location is going to user hive warehouse, right? And we have said that whenever we create an internal table, whenever we create this table, my data is always going to this directory in HDFS, which is user hive and warehouse. After that, we have database name, table name, and our records. So user hive warehouse, this is root and subroot. May.db is my database name. Text info is my table name. Input format. By default, it is storing all this data in a text input format. And by the way, this is not new to us. We have seen the same thing in Scoop also, in MapReduce also. By default, all they use is text input format. However, we can change it according to our application, which I will do later in this session. Text output format. Are we using any serialization technique? So we are not using any compression or serialization. Bucketed, have we used any bucketed? This bucketed and partition is one of the key concept of Hive. We'll use this bucket and partition for optimization purpose, right? Currently, first we are learning how to load the data. So After understanding the basic behavior of Hive, that how to load, how to insert, then we'll go to optimization. Because whenever we write a program, okay, every programming language we segregate in two different parts. First, how to write the code. So first I'm focusing on writing my code, reaching to the program or the business logic and implementing it. Once this is written well, running, compilation is done, I've created bytecode in the run in the run side. Then second is my optimization technique. Then I will try to decrease the line of code. Maybe here I have written 1,000 lines of code. So here I'll be doing, how can I decrease this from 1,000 to 500? How can I decrease this from 500 to 300? Can I do this in 100? This is what is known as a optimization. So do not focus directly on the optimization. First check how to write this. That's what we're doing. Bucket and partition, we'll see. Sorting the columns, have you any sorting things? Currently no. Skewed info, not required. And this table type, the last value, this table type is a managed table. What do we mean by managed table? This is another way to call internal table. So internal table is also known as a managed table. Remember this name. Managed table and external table we call, or internal table, external table. Interchangeably, I can use both of them. So if I'm saying managed table means I'm talking about this only. So this is giving me detailed information, but still in clumsy form, right? This looks difficult to read the data. So can I mark them well in this line? And to marking line by line, I have another command, and that is so create table in table name. If I type this, I'll get a proper DDL. If I copy this DDL, paste in my mail, and I'll share this mail to you, so you can copy and paste in your cell, your table will be created. So you're not putting any extra effort. So this is giving me a good DDL information. How many columns, and actually this is giving me the same data, but only in the formatted way. This is the formatted information. This table is empty, but currently, okay. Can we check their meta store? So where is the metadata storing of this dummy column and text info? So one more time, we'll see the graphical representation because that's important, I feel. Hive is writing this data to HDFS. This is the storage point. Currently, we don't have any data, that's why I cannot check this. Hive will run any DML query, remember. Hive will run any DML query, only DML, not DDL, not DDL, not DRL, only DML query in this MapReduce. What is the internal flow or architecture? We'll see that later. And Hive is keeping their meta store or metadata in database. And this database is, it can be anything. In Cloudera, this is by default set as MySQL. Okay, this is by default set as MySQL. So metastore will go in this MySQL. Now, in order to check this metastore, I will have to type in my terminal how to access MySQL. MySQL u root -p. Then I'll give password as Cloudera. Then I can go to MySQL, and people call this as SQL. My habit is in SQL, so I'm talking about this one only. MySQL u root -p Cloudera. Okay, I can check database and information in this. Now, where can I find this all the property? So all this property is set in Hive folder, and Hive folder is present in your user lib Hive. This is the by default folder for any module, because user lib it can be only accessed by administrator or the root user. That's why we're keeping all the module inside this lib. First, we'll go and see the property which we set in Hive are already done by Cloudera. That I can find it out from terminal. So cd user lib and Hive. Enter. Now you'll have to go to conf folder, list. This is the file, hivesite.xml. So all the property you are setting here. Now, if you are interested to set all these things manually in your machine, okay, so you can text me in a mail. I have file. If you're interested in the admin activities, I can share that file. But currently we're in the development section, so I'll not go to set this all the files. This is already set in my machine. Hive site.xml, and the same thing is set in your machine also if you're using Cloudera or GCP. Hive site.xml is a file. This is currently keeping all their meta store in MySQL. This is the database name. What is the driver they are using? This is the driver property, jdbc.driver. Now, what is the connection username for Hive? The username is Hive itself. What is the password? Password is Cloudera. So this many information is already set here. I can go and see some other information also. So we're just verifying it where the main properties is set of Hive. Just like in Hadoop, we had 4 files: core site, map rate, yarn, HDFS, and Hadoop env.sh. Here we have just one file. This. Now I want to go to MySQL database. So MySQL u root -p, and this is root. Oh, sorry, this is Cloudera. So databases, and what is the database name? Metastore. Use Metastore and show tables. So your table information goes to this table, which is TBLS, and your column information goes to this table, columns underscore v2. Check them. Select the star from TBLS. So I have created one table, and this is the last entry. You can see the last row. Text info. This is the minus table. Based on the timestamp, this is created today. Who is the owner, and so many other information. This is talking about the table. How many tables are there? Now, can I see their metas, their column name? So select a star from columns underscore v2. And last entry, if you see, this is the last entry for my column dummy, which I have created in that text info. So this is the meta store location where your metadata will store. Can we go and see data location? So to check the data location, we can exit from here, and this is going to hdfs dfs minus ls. We know by default directory is user hive warehouse slash database name, that's may.db. By the way, if you want to see how many databases present, you can check till this directory. I'll give may.db and my table name. So whatever is table name, one folder will be created with that table. So this is the folder, and currently it's blank because I do not have any information available in this table, right? So this is blank. Now let's load this file, sample.txt. We'll load this file from here to our Hive table. Now I have two options to load the file. I can load it from local also, and I can load it from HDFS also. Option number one, load. I'll write the syntax here. I'll perform both the operation. Load data from LFS. LFS stand for local file system. So in Hive cell, I'll have to run a query, load, and we know this load is doing bulk loading thing, right? This is like a bulk load. So they'll take whole file and directly load into your table. Load data, and you're taking this file from local, so you'll have to give a keyword here, local in path, and within this single quote, you have to give your path. Whatever is the path, I'm just writing the syntax currently. Path I will define. Local in path, this path, into table name, into table name, and semicolon. This is a termination, by the way, statement termination. Once you run this query, then automatically this file, okay, what this query is doing, let's understand. This file will go from this location and load into this table. This is from local. Suppose I have some input available in HDFS. So load data from HDFS. And my query will be load data. Just one tiny difference. Here I'm using, let me actually highlight this. Here I'm using this local because I'm taking it from local. Here I won't be using any local because my data is coming from HDFS. Now here this query is load data in path. I'll directly write in path, and then that path into. So please try to understand this logically, because if you try to rectify this, you'll forget. That's why I'm specifying this is local, this is non-local. Into table name. This is the query when I'm loading data from HDFS to a table. Okay, just one difference. And this is doing a bulk loading. So let's try this from local first, and then I want to try this from HDFS. Query load data local in path, and don't just give a file name. Okay, we do this silly mistake sometime and confuse that why this is not taking. So always give a absolute path, not the relative path, to avoid this mistake. Home Cloudera, file name, into table, and what is your table name? Text underscore info. Currently this is having just one row. If it is having 1 billion or 1 million also, it will hardly take 2 to 3 seconds, because what we have already proved in Hive site, that they are not checking the schema while loading. That's why they work with the concept of schema on read. So when I run a query, that time they will check the schema, not while loading the data. Okay, that's why this is faster. Now since your data is loaded into this table, read this acknowledgement, loading data to table with number of file, with the total size in bytes, with acknowledgement and total time taken by your system CPU is 1.506 seconds. Now can I run a query, select star from table name, text underscore info, I can see that data is mapped with my column dummy, and this is having the data. Can I verify this data from HDFS also? So in HDFS, I will rerun this HDFS DFS minus ls. By the way, I already submitted this query, so I'll use this. Now you can see this table is just kept a file sample.txt 2 minutes ago. Can I see this data here using cat command? By the way, this is the same data. Which is pointed by your Hive TDL. This is from low LFS. Okay. Now, can I check with HDFS command as in load from HDFS? So to load from HDFS, first I need to put this data from local to HDFS. And what is the command to copy the data from local to HDFS? That's a put. HDFS DFS hyphen put sample.txt, and maybe you can keep this anywhere. Let's keep in the root itself with the same name. Check this HDFS DFS ls and slash. So we have this sample.txt records available with some size which is 54 bytes. Now I'll run the same query, in fact exact same query. I'll just remove this keyword local and I'll give my file path which is sample.txt. Remember, when you're loading this line, okay, what will happen? You already have one file stored in this table, so this will not override it. This will append it, just like we do in insert. Okay, so by default, they're not overriding your previous information. What this query will do, if I submit it, this will make one more entry. So in my table, one entry is already there, which is this entry. So it will make one more entry, which means I will get this line 2 times now. Let me do that first. So now I have loaded, and number of file in that table you can see coming as 2 with 54 into 2, which is 108 bytes. Right? Can I run same query again? Select a star from table name. So this is appending the line. Now suppose I don't want to append this. I want to override this. Maybe while writing from local or in first copywriting, I made some mistake and I want to override my previous information. I want to keep the new information. So before into, okay, before this into, you will have to use override. Now when I type override, then it will delete the previous data and keep just one data, one line. So we already know the concept of override, right? This deletes the previous information and keep only the new one. Keep only the new one. But so far what I'm doing, this is load thing, right? Bulk loading. Can I try to make some insert here in this record? In this column. So if I try to insert, what was the difference between load and insert? So for beginner, this is very important to know the difference between load and insert. Load is not a DML, remember. Load is not a DML. Load is just like taking one file and directly entering it. But insert operation is a DML. Okay. Now, when you type this insert query, and this insert query I'm going to run as per SQL syntax only. So syntax is this: insert into, okay, and insert is one insert at a time, or maybe 5 insert at a time. I cannot do millions of insert at a time because I need to type that all millions data here, which is not practically possible. So insert into text underscore info values, and here in double quotes I can pass anything. Maybe I'm saying this is a HTML query going to take a lot of time. Why? First I will submit this, then I will explain you why this is taking time. Read the log file. The moment I submit, it will start creating one query. So this is the query, total number of jobs. Then I can track the job also from here. Now reducer will not be there because I'm not doing any aggregation, I'm just inserting it. So number of mapper will be there. And this is all by default set in Hive cell, which I can definitely change mapper and reducer. This number is set in Hive cell. Okay, currently I can check this, what number of mapper and reducer is set, and I can customize this also as per my requirement when the data size is bigger. Read the query in first map 0%. There is a 0 reducer, by the way, and number of mappers 1. I'll tell you why this is 1. I'll read all this log file. Okay, just bear with me. MapReduce total cumulative time, CPU time, is 2 second 680 millisecond. This is the total time taken by CPU to insert the record. Then multiple stages we have to complete the query. Then now number of files I have 2. Number of rows is inserted 1. This is the new row. Total size has changed from 54 to 106. Maybe this is 52 bytes, and raw data size is 51. Let's go and run our select star from table name again. So when I type this, my record is inserted and new entries at first row. This is a DML query going to take a lot of time. Data is inserted, but interesting part is the architecture of Hive. Now here we are going to see Hive internal flow. Now this is what is important more, because query I can run any query and see the output. But when optimization will come, I need to know this flow part. I'm running all that query from my interface, right? So this is my interface. That cell I'm calling as an interface. And from the cell, insert query, right? I'm submitting that insert query, insert into table values. And within bracket, I have passed a line. This query is first going to driver. And what's the driver, by the way? We have seen this in the Hive site XML. JDBC is the driver. There, well, we have 3 other driver: JDBC, ODBC, and thrift drivers. Thrift drivers, ODBC, I will take in a while. Currently, this is a JDBC, Java Database Connectivity. Now, after this driver, they are going to compiler to compile your query, and this compiler is going to metastore. And this metastore is what? This is MySQL. We just went a few minutes ago to check our table name and there is schema inside the table as an entry inside the table. Now once this matches with the meta store, what they are matching in the meta store, they're saying this insert query is passing just one entry here, right? This insert query, we are passing just one entry here. So my meta store will check in this table, which is text info, this table, text info, how many columns are present. Since my just one column is there, that's why mapping is perfect. One entry with one column mapping. Since the meta store is matching, then metastore will acknowledge back to compiler that yes, the entry which this interface has submitted, this is matching with the metastore. Now you can compile it. Then this compiler will go and seek a help from their execution engine. And what is the execution engine in your Hive? You can check that using a query set hive dot execution dot engine and enter. This is set by default, guys. I can change this to stage and spark also, but let's use the by default one first. We'll understand all three flow. This is MapReduce by default set. And if you know the MapReduce flow internally, what MapReduce do for any job, let me write the MapReduce flow again. And that's why I said when we're learning MapReduce, this is going to be the very important topic for rest of the module. MapReduce flow is taking your input data from the query, taking this input data from the query, then creating input split, and based on what they create the input split based on the size of this data, and this size was just 52 bytes. This size was just a 52 bytes. So 52 bytes means how many block? Just a one block. It needs actually just one block in HDFS to keep this record. Now since this is one block, so how many input split will be created? Just one input split, right? Then this input split is going to mapper. Mapper is performing one operation, which is a map task. So in map task, it is providing key and value. Okay, it is providing you key and value. After this mapper, if I write traditional MapReduce flow, then this is going to be a combiner. Okay, well, this is not happening in my current query, but just as a part of a standard flow of MapReduce, I'm writing it. Combiner, then partitioner, then shuffle and sort, then shuffle sort, then reducer, then output. We have record reader and writer in between. Okay, that's internal step. Now in my query, in my this query, there is no number of reducer, right? Can you check it here? Number of mapper is 1 and number of reducer is 0. Why this is 0? Because reducer will only invoke by CPU, okay, or considered by your query when you are going to perform any aggregation. Aggregation is like group by, sort by, order by, sum, count. This is all aggregation query. If there is no aggregation, then there is no reducer. And I know if there is no reducer, my query is anyways going to perform 50 times better than if I have reducer. So if there is no reducer, number of mapper is one. By the way, number of mapper will be one because of this data, and reducer is set as 0. So this operation is not happening. I'm directly getting this output after mapper stage. This is the graphical presentation, but technically you can see here, this is 0%, 0% when job is submitted to application master. Then mapper is 100% done, and still reducer is 0%. Then once the mapper is 100% done, you get the output and you get the acknowledgement that this took total 53.177 seconds to operate this. Now once this output is done, okay, after mapper, this output will store in HDFS. This output we are getting in HDFS, and this I can check using my query again. HDFS DFS -ls. If I go to this directory, user, hive, warehouse, my database name, my table name, text_info, and it will have one new entry. Okay, let me go there first and check this. HDFS DFS -ls, user reward query, user use ls, and table name. So this is my previous entry, which has previous file. This is the file, by the way, and this is the record. If I read this record 00 underscore ncat, I'll see that entry. So the moment I do insert and insert, every time they're going to create a mapper, and every time it will have a new entry in this text info folder. Okay, so MapReduce flow is this. Now go back to HiveFlow. Compiler has given this query to MR, which is your execution engine. So this is your execution engine. Now this execution engine will submit this query to whom? This will submit to resource manager. I'm using a short form RM. This RM is a resource manager. This execution engine will interact with this using the port number, and that we know, 8032. Then this resource manager will check from yarn that do we have any CPU available to perform this operation. Resource manager will assign this task to node manager. Node manager and data node both are in same machine, right? Node manager and data node both are in same machine. So node manager will process this based on their available CPU. So suppose I have one CPU available on this machine. So one CPU will operate this. They will take some X number of time. This is based on my processor speed. X number of time it will take. And once they process it, they will write that output in this data node in the same machine, because this data node is nothing but a collection of HDFS, right? Since I have just one data node, currently this data is ultimately going to HDFS. After submitting that output to HDFS, it will revert back to resource manager. Yes, I have submitted the job. So this is the job submission. This is the acknowledgement. Resource manager will acknowledge back to execution engine that your query is done. Execution engine will communicate back to compiler in form of acknowledgement. Compiler will communicate to driver again, and then driver will display you that output in interface or the acknowledgement. This is what? One second. This query you're seeing, this is the acknowledgement that time taken 53.177 seconds and this is done. So whenever you do any DML operation, remember, let me write a note here. Whenever we perform any DML operation, especially IUT, the above flow is going to compile. Always this flow will work. Okay, and how they're deciding the number of mapper and reducer, I hope you understand that. Based on the data set, if my entry is more than 128 MB, the number of mapper will be more. Like I'm doing from one table to second table, I'm trying to load data which are more than 500 MB. Okay, so suppose I'm doing insert. Okay, because this insert can work from one table to second table also, table 1 to table 2. Load is a file, loading the whole file in table. Insert is table 1 to table 2 communication. This is like intra-hive communication. That's why intra-hive communication, or I can call it as intra-hive table communication. Well, both are same thing. Now, when I do table 1 to table 2, and let's say in table 1, I have total 1.1 GB of data. Okay, this is the total record available in this table. And from this table, I want to insert 528 MB of data. I'm just assuming the number, okay? Out of 1.1 GB, I want to write this much of information from this table to this table, and this all the data is present in this table 1. So how many number of mapper they are going to release? That's one question. How many number of mapper they're going to release? So your job is to simplify this when you divide this number by 128. So can I do that? 128 MB, 128 MB, 128 MB. This is how much? 384, and 528 minus 384. If you subtract this value, 4, 12 to 9, 3, and 134. The last entry will have 134 MB. So total number of mapper they're going to create: number of mapper 1, number of mapper 2, number of mapper 3, number of mapper 4. As in 4 map task will be there to perform this. And rest thing we already know. If 4 map task is there, and if I have 2 CPU available in node manager, then 2 tasks will process in same time, like simultaneously, using the multi-threading approach. Just 2 tasks will be submitted to 2 CPU. Once they complete this in, let's say, 61 second, then another 2 tasks will be submitted to, again, once they complete it, they will acknowledge back that we have completed. So they will release the CPU. They release the CPU. Once they release the CPU, that other 2 tasks, which is M3 and M4, will again submit here and take maybe 63 seconds. So my total cumulative time, okay, you're seeing here one time as a cumulative time. Can you see it here? Total cumulative time. So since there is just one mapper, that's why the time is total 2.68 second. But suppose if I have multiple mapper, then this cumulative is what? Is like we are adding the previous value also. We're adding the total time. So 61 is my first cycle time. 63 is my second cycle time. So total time would be 124 second. This is nothing but my cumulative CPU time. Cumulative CPU time, if it is taking this much time. Okay, because the data size is high and maybe I'm using a 3-2 processor. So they're having a processor type also. So number of mapper is clear. Reducer we have not yet seen because we are not performing any operation of the aggregation. How internally they will submit any IUT operation. Okay. Remember, load is not a DML operation. So when I do load thing, this flow is not going there. That's why the load job was done in just 1 second of time, and insert of one row is taking this much time to complete this. Now can I check number of mapper and reducer which is set by default here? So set hive or maybe map reduce dot map once again hive dot map dot hive mapper. What was the query? Let me check with set-v. Set-v is a command to check all the options of your properties. So you can scroll up and see this. I'll check, I think that later. Okay. I need to Google it up maybe. I'll see that later. What number of by default mapper and reduce list. There is one property. Okay, I forgot that property. I'll tell you that later. What property is there? So now we know how this insert query will work, how this load query will work. Second thing, can I drop that table from here? So if I drop this table, I'm just dropping this table to prove the point. In internal table, we say when we drop the table, my data and metadata both gets deleted. My data and metadata both gets deleted. So drop the table. So tables, drop table text info. Check this. So tables, it's gone from here. Check from your this directory. Data is also deleted. And now we'll go to MySQL. So databases. By the way, this database is metastore. So use metastore. So tables. Select a star from TBLS. Last entry was my text info. That's gone. You cannot see anywhere that table entry here. Now second columns underscore v2. Why this property is very important, we'll see when we start external table. So a string, dummy and a string is also gone from here. So metadata is deleted. Point first is proved. Then we are saying insert let's go here and see how to check number of upper and reducer set in Hive cell. Map rate reduce task. Okay, we are in the right. Map rate dot reduce dot task. Okay, this is a number by the way. Okay, map rate dot reduce dot task and map rate dot map dot task. So by default, this is set as 2 and -1. A hyphen flag, this is like 1 only. Okay. So can I change this to any other number? So yeah, I can change this to any other number. Just I need to pass the value. I can say reduce dot task and is equal to, let's say 1, or I can say 2 also. So earlier this was -1, now it is changed to 1. What is the significance of -1? And 1 will say in the flagging part. So this is the to command. Okay, there are so many properties actually, so we should write this down. Map rate dot map dot task. This is for checking the number of mapper, and map rate dot reduce dot task. This is to checking the number of reducer. You just have to set and semicolon. Now if you want to see all the option, obviously I believe that there are total 934 some properties are there, so you cannot remember all this. Okay, so one option you can remember, set hyphen v. So this is like help command for you. You can check them from top to below one by one. Second will prove how Hive is working as schema on read. We are talking about this point now. Case A, schema on read. So my table, I'll create one more table to perform this query, and my table name is create table GDP, and this is specifically to India GDP. I keep year. Okay, here is my column name, and how to keep date as a data type. We know date is a standard data type. So in which year, what was that GDP, and this number. This is in double. Then enter. Row format delimited, because if I want to make multiple entries on the row side, I'll have to give this, otherwise control M character will be there. Row format delimited and fields terminated by, let's say I'm giving pipe this time, this pipe. So this is the termination between year and GDP. Create this. So tables. So create table and table name. which is India GDP. This is 2 column, fill delimiter. What else? Text format is by default. Still, this is the internal table. Okay. So far we are saying internal table. Now I will create a file cat and gdp.txt. Here you can write it in the format, and here you need to remember the format YYMMDD, right? This is the format YYMMDD. Strictly format for date data type. You cannot use the combination. I have given the reason yesterday. 2015. So I'm checking from 2015, and this we are checking on year ending 31st March, and I'll give tab, then I'll give the GDP rate. I'm using some value 060331. This was captured as 5.70331. This moved down to 5.1, 20170331. This is somewhere to 6.3. Sorry, this is for 180331. 2019, it was in 5.9 again. So this is the 2 columns record. Now I want to load this file. This GDP is a file, right? When you want to take this complete file, you use the load command. So load data local in path and give absolute path home Cloudera and file name, which is gdp.txt, into table name, and table name is ind underscore gdp. As I said, this is case insensitive, so uppercase lowercase will work. File is loaded, size we can see, time also we can see. I think this is less than a second in fact. Now can I run a query to check the record? Select a star from ind underscore gdp. And the interesting factor you will see here that all the results are populating as null. The question is why? Why all the result is populating as null here? Anybody? So my data is loaded. Okay, I did not get any problem here while running the query. This query, I did not get any problem. This is giving me proper acknowledgement. I'm getting the output, though the output is not giving me which I'm expecting. This is coming as null. And why this is null? Because Hive has done the job on schema on read basis. I'll tell you stepwise. So I created the table with delimiter pipe. Okay, I created this table and I gave that this fields year and GDP are separated by pipe. Internally, I have defined this to my DDL. But while creating the file in this terminal, can you see any pipe here? This is tab. This is tab. So since this is tab entry, data is loaded, but data is not coming when I'm running a query. This is exactly telling me first they load the data without checking the schema, without checking the schema, and when I'm running a query, which is my DRL, this query. That time they are checking the schema and returning me null. So one thing to note, if your schema is not matching, or maybe you are giving just one column entry and you have two columns, so second column will be null in that case. If your schema is not matching, the answer is in front of you. It will populate as null. Now, can I go to HDFS and see what result is there in HDFS? In HDFS, it will have the proper data, which I have loaded. So HDFS, DFS, since I remember this, I can directly go, but how you guys will check this directory? You have this command, right? So create table name, and this is the directory. I can just copy from here, go back to directory and type HDFS, DFS -ls and paste this. This is the gdp.txt. What do you say? This is null or a proper data? This is having the exact information. Okay. This is having the proper data, which was there in my local. Now, if you're interested to know why we have this concept in Hive, so don't think about the one file or two file. Currently we are learning the concept and scope, but once we go to production system and we say that we are working with a big data definition itself is, so there is no definition of data which are beyond terabyte, then only I'll call a big data. It's a collection of multiple units, okay? But obviously the GBs of data, I cannot call that this is a big data. In real time, we are definitely taking more than TBs. So if I'm loading more than TBs data in Hive, and this is working with the concept of schema on write, right? This concept is there in by default RDBMS, and that is the reason today we're rejecting this, because they take time to load the file. They're checking a schema one by one. So if this is TB of data every day, like I'm wasting my time. Maybe I would be able to load this whole file in 1 day or 2 days, which I could do in Hive maybe just in 5 seconds. So that is the reason, since Hive is specifically built for this concept, we have this thing. Now, second point, can we manage this data to read with a proper format? So obviously, if I know the entry is wrong, and I did this intentionally just to tell you what is the schema on read means. Now I'll open this file again using VI editor, and I'll change this delimiter. I'll say this is pipe, this is pipe, this is pipe, this is also pipe. And let's say for last record I don't give pipe, okay? Let's say for last record I don't give this pipe. What will happen in that case? I will reload this, but one extra keyword I will have to write, because I want to delete my previous entry, right? So I'll say overwrite into table name. Run the same query. The rest of the record is formatted well, but the last entry is still null because the delimiter is still tabbed there. So I hope this is clear. What is a schema on read? Now suppose I pass just one entry, okay? While inserting this data, I said insert into table name, which is ind GDP, and I'm giving only the value, which is my column to GDP. Insert into table name GDP values, and I'll pass just one value for this, which is way less, I think 2.9 somewhere. Enter. this is insert query again. So whenever you write this insert query, what is happening again? Number of mapper is going to be 1 because your data is running, your Hive is internally running this operation again. The flow is same, and since you are writing just one line, just one record here, so what do you say? This record is more than 128 MB or it is less than 128 MB? So obviously this is less than 128 MB, and hence the number of mapper is going to be 1. Reducer will be 0 because this is not a aggregation. I'll run one aggregation query after this command. Then you will see number of mapper also, number of reducer also. Enter is done. And I'll run the query again. Select the star from GDP. You can see, since I have just given value for, one second, where's my query? I have just given value for GDP column, only for this column. That's why I have given entry for only GDP column. That's why the values 2.9 is there, but first column, which was year, I did not define, and hence they are taking by default null. So if you do not pass anything, I'll repeat it again. If you do not pass anything, it will keep null. If it is not matching with the schema, it will keep null. Later, when you do aggregation, that time they will tell you, okay, this is the entry. Now one more thing. So far, I'm just running insert query. Can I do count operation? So I want to run one aggregate operation. I say select count star from table name, and my table name is INT-GDP. This will take a time, guys. This will take maybe a minute because this count star is an aggregation query. And since this is an aggregation query, number of mapper, before running the command, I will tell you this is going to be 1 and 1. Number of mapper will be 1, reducer will also be 1. So this is actually even a question. When you type this query, question can come, how many number of mapper and how many number of reducer is going to invoke. So it's a FAQ. Let's see this. You can see, right? Number of reducer is 1. So mapper will also start and reducer will also start. So this will take more time because my CPU is processing map task also and reduce task also. And MapReduce, we know, is a disk computation. So whatever output of this mapper is released, whatever output is this map task is releasing, this output goes to intermediate location. If you ask me what's the intermediate location, this is my disk. This is my hard disk, right? So since this is my disk, when reducer is doing any operation, again this reducer will read this file from disk and taking time to process and aggregate and give the answer. So answer is 6 because we have 6 row. Count star tells you the row. This is your first row, second row, third row, fourth row, fifth row, and sixth row. So this is a row, and you can see the output that 6 is an output. Now, the schema on read is also done, and this entry is there in HDFS. Okay, this entry, if I go to HDFS, I can see the proper entry in HDFS also. like this null. Actually, I have given just one entry, so I'll show you this is new. Go back to table again. So one entry jdp.txt, that's the file, and g000. I'll give a star and cat. Can you see there is a slash n? Okay, so by default it is internally reading that information as slash n, and in hive side they're giving you null. Now time for external table. Okay, so external table, let me create the same table with external table. No changes, record will be exactly same. So I'll say create, and actually let me drop this first. So tables, whenever I do insert one, this entry will be there, and this will hold the same entry. If you want to see this also, whatever the more number of time I do insert, this values will be created. Select a star from values underscore tmp. This is a temporary table, by the way. It will be deleted obviously by default by 1 or 2 days. So this is the entry which I just did, 2.9. That one thing is my previous entry, which was the DML query. So whenever I do insert, this temporary information should be created. Okay, so now external table, create, yeah, GDP drop table. So I'll drop this table also, values underscore tmp underscore table underscore 1 and 2, all blank, call empty. Create, this time I'll say external table. Okay, and I'll give table name itself as gdp 20. Year is date, then uh, gdp as double. Enter. Row format delimited, fields terminated by, this time I'll give field tab. Okay, let me give comma, fields terminated by comma. One extra line I will write for external table, that this is going to store in this location, because in external table user will define where this record will actually store, not like internal table. Internal table is taking by default to user high warehouse. Okay, location, guys, I can write anything. I can write uh, let me write in the format of year. So year I'll say 2020, then I'll say date, which is 17. Before date I'll say month, date, I'll give this. Then I will load the data, load data local in path. And just to correct you, if I again run this query before changing the file, it will hold null data again. So first I will go and change. Sorry, there's a connection gone. So let me connect with mobile. Hello. Actually, there was a connection gone, looks like. Okay. Am I audible to you guys? Please confirm me. Thank you. Yeah. So there's a slight connection lost. Uh, I'll start from here, by the way. So this is the query, okay, into table name, and load this file now. Before loading, as I said, I need to change this to write format, and all these are separated by comma. And save this file. Now we'll load it. Uh, what happened into table? Sorry, table name is GDP 20 only. Run the query, select a star from table name again. Select a star from GDP 20. So you can see the result. That's proper, well-formed result we can see here, right? Now this data is present in this directory. So to check that, I can run so create table in table name, which is this. And where this data is getting stored, so this data is getting stored at this location 20200517. Copy this. Earlier it was user high warehouse, right? If you remember. Delimiters changed, comma, SDFS, DFS minus LS, and paste this. Read the file gdp.txt. Okay, these are my records, actual records. So what you did, just you have your Hive schema or DDL is pointing to this file. This Hive is ultimately pointing to this file in HDFS, and whenever you're running any query, this query is scanning the result. This query is actually scanning the result from this folder only, from this gdp.txt file and the 17 folder. Now this query can be anything, can be where conditional query, can be count query, can be insert query, can be update query, can be group by query. I can do all the query which we already know in RDBMS. That's 99.9%. Additional queries also we have in Hive. So far this is external table. One more property of external table I will tell you. Okay, so one more property of external table is this. Say you drop this table, right? Now what query I submitted for internal, the same query will work for external also. The difference is only one line. External table does not drop the data. When you drop the table, it only drops the metadata, while internal table will drop the data along with metadata. We already verified the internal table. We'll verify now external table. Can I drop this table just to test this out? So tables, metadata entry I will check. So MySQL u root p and Cloudera. Use metastore, since I know that database name, select a star from TBLS. Can you see any GDP20? No table entry, it's deleted. And second table is columns B2. I'm sure this will also be deleted. There is no year column and GDP column. That's about Metastore. Go to HDFS and rerun the same command again. And I'm sure that result is there. What is the query? HDFS, DFS, gdp.txt. Data is still present in HDFS directory. What is the benefit now? So currently you have data. Currently you have this data in HDFS. This data is present in HDFS, but you do not have any schema available for this data. So can I go again to Hive and create one schema for this according to this data set and pass this to this table? This is how we can do an external table. So if some file is already present in HDFS, if it is external table, no need to load it. Just create the table and point them that this is the location. I'll create one more table to explain you the case number 2. First I will do this. I'll create one table and I'll just point to this scheme. I'll not load it now. This data is already present in HDFS. Remember, I was loading my record to Hive because data was in local file system. Since this is already present in HDFS, then I will not load it now. I will run one query. So create query same, then row format delimited, then fields terminated by, and then I'll pass the location of it. Can I run a query again? Select a star from table name. The data is present. I'm not loading anything. I just created a table and I pointed to this location. You can see it. This is important part. So always point the folder, not the file. Okay, sometimes we make this mistake to point the file. Do not point the file, always point the folder. Can I do one more thing? So if I directly load one more file inside this folder, okay, let me create one more file with the name cat underscore gdp1.txt and date 20200331 with 2.9. Enter. Sorry, I made a mistake here. I'll open this file again, gdp1. This is comma. Earlier it was dot. Now I'll load this data using put command to copy it this directory. What do you say? If I run a query, will I fetch this information? Let me run that. You can see it here. Last entry is immediately coming as soon as I put my record from local to HDFS. So this is what external can do. Okay, let me tell you one thing. Actually, I'll connect this with Scoop. So you are taking all this data from RDBMS. That's one. If you're doing historical data analysis, right? This RDBMS is one source. The source can be anything. I'm just taking example since we already have taken all the data from HDFS to RDBMS to HDFS using a scoop thing. And this data is present in HDFS. Maybe I have one company data which is a bank. I take always bank in e-commerce example because they are having data data since last 100 years, 200 years old. So their historical data is very high. Now this bank is taking data from here to there, and this is last 200 years data. Very old bank, say Barclays. And this 200 years bank data is going to HDFS, and now this data is present in some file in HDFS with let's say 5 billion rows. Terrific high volume. So 5 billion rows is present in this file. Now schema is missing. So I thought to create one table in Hive, which is one external table. And in this external table, when I'm creating this location, so I'll directly point this file. If this file, okay, if this file is present, so let me actually map with the query. I will run a query to extract this result, and this is the query. In scoop, I'm running scoop import hyphen connect JDBC MySQL IP address database name. I'm writing the syntax. Then username, some username will be there. Then password. Then table name, some table name will be there. Let's say this table name is transaction table, TXN table. And the target directory I'm giving as big data 200, because this is 200 years record. Okay, this is the directory name, and in this directory this file will go. And number of mapper, since this is a production table, so let's say number of mapper I'm giving 8, because I have 8 parallel CPU available in my cluster. As soon as I submit this query, it will start fetching all this information back to HDFS. Once this is done, I get the result. Then I will go to Hive table, create external table, and pass this location. And what will be this location, by the way? This location will be, I hope you understand what I'm trying to say. Location is big data underscore 200 here. That's it. I'll pass all the schema, okay? Create table statement, and then within bracket I will give column name, schema type, row format delimited, fills terminate, all that standard form. And at last I will just pass this location. And I'm pointing actually the location where my scoop has extracted this result. So you connected the dots, right? Without loading any information, just in Hive you pointed, and then you can run a query that select a star from, let's say I want to see this result, okay? How can I run a query? So if I want to see that specific result, I can run, guys, any query here, by the way. Let me do that. Select a star from GDP 20, where GDP is more than 5.0. Enter. This will only fetch result which are more than this. Okay, can I say so year wise we have just 111 entry. Let me use a group by query. So select a star from this we have seen. Then can I say select year when this is more than 5.5? Tell me the year. You can see only in this 3 years this is more than 5.5. Then group by, and I'm grouping this based on the year. Well, we do not have any repeating records, so this is on year, and count star. Enter. This is again aggregation query start reducer. So just to looking at the query, actually once you know the flow and the internal thing, you can tell how many number of mapper and reducer is going to work. Let me have a quick question here. So if I'm asking you guys, try to answer, okay? I have this result available in this GDP table. In this GDP 20 table, I have say total result available 200 MB. Okay, 200 MB is total data. Now, out of this, out of this, 150 MB data belong to 150 MB data belongs to one specific country. Let's say that's India only, and other 50 MB data. Okay, other 50 MB data belongs to some other country, maybe Australia. Now, this is the table. This is the total record. This is the India data. This is the Australia data. Now, when I'm running a query, select star from GDP 20, where where country is equal to India. Suppose that's my query. Can you guys tell me the number of mapper and number of reducer here? I'll wait for a minute. If you can read the flow again and want to process based on that, you can use the calculation and try at least to give some number. So only two answers received, but I'll tell you, okay? I'm not looking for the right or wrong answer here. I'm just trying to make this session more interactive. So if you can interact based on the query, so that you'll be having the question in the question which we face in interview will be easy for you. So I'll tell you the answer, okay? Actually, number of mapper and number of reducer. So three answer received, but we don't have any right answer received. As in we have not yet any right answer. In the panel, the mapper is going to be 0 and the reducer is also going to be 0. Guys, again, this is what is a confusing question. I'll tell you why. Because I am asking you query select a star from GDP 20 where country is equal to India. Okay, this is just scanning it. This is just doing the scan part and giving me the output. Do you see anywhere when I'm running a query? When I'm running a query where condition with, do you see anywhere my number of mapper or reducer is getting invoked? If I run this query, I will run this query, okay, just in time. If I run this query, why the number of mapper and reducer is 0? First, I'll explain that. Because you are not doing any, this is not a DML operation. I've clearly specified when there is a DML operation, then only your MapReduce flow is going to initiate. If it is not a MapReduce flow, then it is not calling any mapper reducer. And since this is just a DRL, retrieve the data which are related to India. So people who have answered 2 mapper and 0 reducer, I understand your internal thought process. Well, you're going in the right direction, but the direction is little bit wrong, because you made a number of mapper, I think, based on this, right? You said if it is 150 MB, then 128 MB is one mapper and other 22 MB is another mapper. So, partially right, okay, let's say partially you're thinking right, but this is not a DML, right? This is not going to perform any manipulation operation. And since this is not a manipulation, so number of mapper and reducer is going to be 0. That's what I did. When I'm searching for this data, that record which are more than 5.5, this is like a where condition only. Do you see any MapReduce job here when I submit this? So when there is no MapReduce job running, which means number of mapper and number of reducer is 0. So let's not make it more complex. Remember just one point. If your query is not having DML, mapper and reducer is absolutely 0 always. If it is running insert, update, delete, group by, count, distribute by, order by, cluster by, we're going to see all of this. Okay, then your mapper or reducer will initiate, otherwise not. Okay, this is one observation. But yeah, appreciate people who answered. Now, second thing, so we have seen the internal table deletion. So far we are seeing comma separated, pipe separated, and comma separated, pipe separated, and space separated. We have even seen the text data also. How can we handle the text data set? Query wise, this is running all the query. Whatever you think from database side, you can perform all that operation. So internal and external basic behavior we have seen in our upcoming class. Okay, I'll just give you one overview what we are going to start. So we're going to start optimization process now. So we know internally how the data is getting stored. Now next class will be focused on optimization. The same optimization we had in Scoop also, right? Optimization, and this optimization we have two topics. First one is a partition, and this partition is, by the way, available in database such as Oracle also. So I've seen in, I guess, 14G or 17G, I have seen this partitions they have introduced recently. And second optimization topic is bucketing. Optimization means I'm running one query. Okay, let me set the agenda. I'm running a query, and this query is taking 20 minutes. This takes, by the way, in production. Okay, I have, if I tell you my experience, I have some of the query which sometime it took me 64 minutes also. I had some of the query which are taking like more than an hour. So obviously, if this is taking, one simple query is taking more than of an hour, then what is the use of working with the big data? Since the data is very big, that's why the 64 minutes they are taking. But now I need to think about this. Then how can I optimize and maybe can decrease this 8 times, 10 times, and just do this operation in 2 minutes or 3 minutes, or maybe in seconds. We have that option also. Okay, we have many optimization technique to handle our query in less time. That's one. Second partition is you're not giving load to one CPU only. Okay, you're balancing the load to multiple CPUs or multiple processor to distribute the load between your CPU and disk. So anytime that this disk computation. As last note for today, if somebody is saying me this is the disk computation and this is the in-memory processing, and their question is which one will be more faster? So we know the answer, I think, right? This disk computation is reading your data from disk and taking more time for any aggregation or any processing, because we do not have any RAM concept here. We do not have any caching concept here. This is big time missing. This is what currently Hive is doing, because Hive is submitting your all the DML operation on which execution engine? It's a MapReduce. Now this in-memory thing is TEZ and Spark. They both work with the concept of DAG. DAG stands for Directed Acyclic Graph. Directed Acyclic Graph. So next class, I'll talk about this intuitively, that how my TZ and Spark is going to perform internally, okay, and how they're faster than MapReduce. So now I have two things. My data loading is also fast, and my query is also fast. That's why that's what I was looking for Hive when I work with Hive. So next couple of optimizations we'll see on our upcoming Saturday.